Hello everyone and welcome to another AP Computer Science video. Today we're going to continue with our class design. We've been focused on creating a bank account class that represents maybe what a bank would have to manage people's money. And we made a class that had 3 instance variables that kept track of the data. We made a default constructor and a non-default constructor and talked about how we can make as many as we like as long as we follow certain rules. And we made accessors and mutators, which are relatively simple methods that either give us back information typically stored in instance variables or change variable values that are data that's stored in instance variables. Today we're going to go a little bit further. We're going to talk about a few other details that can help in design of a class. They're not always used. It really depends on the context in what you're trying to do, but there are scenarios and we should be aware of these keywords and functionalities. So we're going to look back at the static keyword. We've seen it in one respect, and we're going to kind of see it being used again here, both in the original design with methods and in a new way with variables. Something that, again, it's maybe not very common, but it can be useful, and it has a place in Java and the language and in class design as we do that. So the example that I want to kind of implement that is going to force us to use this in a particular scenario is the idea of we should maybe have a unique identifier, an ID, for our bank accounts beyond the name of the holder and the bank and the balance, because it might be easier to sort them by IDs or keep track of them in some way. And so it'd be convenient to have an ID. But we also have to kind of deal with the situation that if we're going to have a unique identifier, they must in fact be unique. And so if we just pick random numbers, even if we give it a huge range, it's possible that we duplicate a number, because the randomness in Java does not guarantee that you won't get the same number 2 times in a row or many times, right? It's a uniform distribution, but it's still possible to get the same values because each call is independent. So we need some way to make this guaranteed. And so one easy approach is to maybe keep track of a special number that we're going to use, and that number is always going to tell us what the next available ID is going to be. And we can always add this to our value as we see fit or whatever we think is appropriate. So what we're going to do is we're going to kind of decide on what's the format of our ID, and then we will try to build from there. Now we're going to make some assumptions. It's not going to be perfect because I don't want to waste time on small details. So for example, if we're going to refer to the account holder's name, it's possible that they have an empty string as their name, but I'm not going to worry about that. So if we call substring, we're going to make it on the assumption that there are some characters there, and same with the bank name. If we're going to use those things, we'll try our best to minimize worrying about the details. Of course, in a real system, you might have to worry about all those little details, but we're not going to do that necessarily for every aspect. So the first step, let's make an instance variable that's going to hold this ID. And again, just like always, all instance variables, and again, I know this is not strictly speaking true, and it's not some language requirement, but for our purposes in the AP design, there is very rarely, if ever, and for the exam, never, a reason to make variables that are instance variables not private. So we're going to make a private variable. It's going to be an ID. It's going to be maybe a combination of letters, numbers, and dashes. So string would be a good type. And we'll call it BID. I'll call it BID. I could put a capital I and capital D. Doesn't really matter, but I'll call it BID. And then we'll say the format is going to be 3 digits, 0 to 9, followed by, so again, that's only a limited range, so that gives us a pretty unique thing if all those are unique, which is fine, but I'm not going to force them to be unique. Then we will say 3 letters chosen from the, we'll say from the account holder name. Actually, let's put this on a separate line just so we can have it all easy to read. So we'll do this. We'll say, okay, so it starts off with 3 digits from 0 to 9. And then we'll say 3 digits randomly chosen from the holder name. A space is found. Use a. We'll say if we find a space, let's go ahead and just pick, I don't know, what should we pick? We'll just put a 0. We'll just put a 0. Use a 0. Right? And then we'll say 3, so we'll do that, 3 digits, and then a dash, right? So that's a dash. We'll say 3 letters, 3 letters, and then a dash. So we'll separate them all by dashes. Oops. and then we'll say 3 letters from the bank name, and then a dash. And then we'll do the last thing, and then we'll say 1 number. I can't spell guaranteeing. Uniqueness. So this is going to be a number. Now, it might start off as a small number, 1, 2, 3, 4, but we're going to make sure that that number is never reused across any bank account. And we're going to do it in a way that doesn't put that burden on the user of our class. Because now, imagine if I'm the designer of a bank account and I say, here's how it works, you have to give them a unique ID, here are the formats, and we then said, you need to come up with a way to protect for uniqueness. But it's on you to figure it out, and good luck. That's kind of unfair, and so if we're designing a class, we might as well go the full tilt and try to protect it as best we can. And so instead, we're going to set up our own thing. It's going to be an internal thing, and so maybe our constructor, once it's been given these 3 pieces of data, will generate this random uniqueness and then put it onto the ID to protect it. And the point is that the user will not know this is happening except when they call the ID and they see it. And they might figure out what we're doing, but it doesn't matter. The point is that we, as the designer of this class, have decided to force that uniqueness, and it's not a burden that they have to worry about, which we could do, but that's not maybe the best design. And we're going to do this on purpose, mainly so we can see some different details that we haven't seen before. So there's our ID, that's what's going to hold. And so that's not too complicated. And so I could put this code into these default constructor or the non-default constructor, but since this is like a multi-step thing, let's make a method. And so will this method be an accessor or a mutator? And the answer is probably neither. And again, that's just kind of an arbitrary separation and categorization, but really it's basically an internal method for us to do the job of generating a nice ID. And then we're going to have to refer to some value to make it unique. So we can do the first part pretty easily. So let's find somewhere and make a method. We'll do it underneath our constructors. So let's make a method. It's going to return a string that is the unique ID. And again, we don't need input because we have access as part of the class to those instance variables. So we know the account holder name, so we could take parts from it. We know the bank name, so we can take parts from it. And we know how to generate random numbers, so we can generate those 3 random numbers from 0 to 9. And then we'll have to come up with a solution for the unique value. And that also will not require input. So here we go. We'll say public. Now, we could say public. We could make it private because we don't want to send other people to use it. But I'll make it public just because that's a standard kind of approach when it comes to our design. The return type will be a string. This method is not static, and one of the reasons, and we'll have to talk about this, and we'll say is, when it comes to methods that are static, if a method is static, it cannot refer to instance variables. Right? So we should point that out. And so this is why accessors could not possibly be static, because they would have to refer to instance variables. And again, the idea is basically static means there is no context besides the method and the input. But non-static methods, the regular methods like accessors and mutators, there is context beyond the method. Right? The context is the data that's associated with those functionalities, the instance variables. Which copy of a bank account do I have? So which balance am I talking about? Right? A static method, for example, like math.absolute value, there is no internal math data that absolute value has to worry about in order to work effectively. The POW function from a base to a power, there is no data beyond the input that is needed or referenced to make it work. There is no math stuff. Right? Even the unique math numbers, our rational numbers, pi and e, those are simply constant values. They're variables that have an assigned value and they don't change, and that's all there is to it. And so it's important that we recognize that there is no context in a static method except the input and the output. But in classes, most of the methods we make do have a context. They refer to particular instance or particular copies data in some fashion. And so we can't use the static keyword in our definition. If we're going to refer to an instance variable, which we're going to, because we need to know the name of the bank and the holder, then we can't make it static. Right? So let's go ahead and make this method. We'll say public string generate ID. And we're not going to say unique just because we assume that an ID is unique. And there is no need for input because we have access to everything we need. The first part. 3 digits from 0 to 9. And so you can pause the video, spend a minute, generate it yourself, and then I'll write code to make this. This is very similar to our first project. We should hopefully be able to do this now. And I'll mention that since I want 3 digits, if you get the number 97, then it should be 097. If you get the number 2, it's 002. So there should be leading zeros. And so that's what we're going to do. And so I'll say pause the video, take 2 minutes, write this code, and maybe generate a number, an int or a string that has those 3 digits. And so I'll start up in a moment. So go ahead and pause the video and try it yourself. Okay, so hopefully you have made this attempt, and I'm going to go ahead and write my implementation, and I'm going to generate a string that has 3 digits, 0 to 9, randomly assigned. So I'm going to say string, and I'm going to call this ID, and so this is our initial value. At the end of the day, we're going to build ID to have everything it needs, but we'll start off with nothing. That's a very typical approach. And we'll say, let's attach, concatenate to the empty string, which will just give us the new string, a random digit between 0 and 9. So I can say integer cast math.random times 10. Right? Because if random gave us 0, 0 times 10 is 0.0, cast it into 0, so I'll get a 0. If it gave us 0.9 repeating, then 0.9 repeating times 10 would be 9.9 repeating, and casting it would be 9. So the range is 0 to 9, and a whole number, and there it is. And then we can do it again. I'm just going to copy this, and we'll do it a third time. Oops. So we do need the cast. It's important that we have our cast. And there it is. So we have 3 digits as a string now, so I can't do math with this, and I don't really need to. But the idea is that we're going to attach these digits one at a time. So maybe it's 0, maybe it's 7, and we'll get 3 digits, and even if they are a 0, so we might get 051 or 210 or anything like that, any combination. The next thing our ID asked for is 3 letters randomly chosen from the holder name. But if we see a space, use a 0. And I'm going to say the same thing's going to be true for this one as well. So I didn't copy it there, but I'll make the same assumption. So what we should do is pick a random spot, check if it's a space. If it's a space, put a 0. Otherwise, put whatever character it was. I'm going to do this 3 times. I could manually, and in fact, what I should have done is let's improve this. This is a terrible approach because this assumes always 3. What happens if I decide to change this to 7 letters, 7 digits? Right? If we're going to repeat ourselves, a loop is a better choice. So why don't we readjust this and make a loop instead? And here's a scenario where I think a for loop is a great choice, and because it basically says if I know how many times I want to repeat, a for loop is a good solution. So I'm going to make a for loop. I'll start I equal to 0, I less than 3, and then I plus plus. And then that's all I'm going to do is I'm going to attach the character. So now, again, what's nice about this is if I decided I wanted 6, I can change this to a 6. Right? And in fact, a better solution than hard coding a number might be to make a private variable that represents how many of these I want. And I could do that too, and that's okay. But I'm not gonna do it now. But the idea is that I could easily do that to make this very flexible. Or maybe pass it in as a parameter saying how many unique digits do you want in the front, or how many random numbers do you want in the front. And then maybe how many characters do you want. So we could really make this flexible, but I'm not going to go that too far because that's not really the main goal of this example. But there it is, 3 times. And so the same thing can apply, and I'll just make sure it's clear, hopefully. I started at 0, and that's just a kind of a traditional choice. And if we count from 0 to 3, not including 3, 0, 1, 2, that's 3 times, right? So this number, if we use a strictly less than approach, is how many times we're going to repeat. It's not 4 times, even though 0 to 3 would be 4 times. This is only 3 times because we're not inclusive of 3. So let's do the same thing for our random letters. We're going to do it 3 times, so a loop would be a good choice. And I can say I equal to 0, I less than 3, I plus plus. And again, 0 to 3 is just kind of a standard. You could do 1 to 3 inclusive with the less than or equal to, or you can do 1 to 4 not inclusive. There's all kinds of combinations, but the idea is that a loop that goes 3 times. So our premise is pick a random letter from the holder name. If it's a space, because remember, the holder name might be a first and a last name, so we have to be careful of that space, or multiple last names, or multiple first names, or middle names. And so we should check if it's a space, we're just going to stick a 0. So let's pick a random spot, and so we'll say string rand letter is equal to, and so we're going to do, and so I need to get 1 character, so to save myself the work, let's pick a random index first. So we'll say ridx is equal to an integer, math.random. We should put our parentheses. and then I need a random valid index. So think, before I write it, I want you to try to write, what is the range, what would I put in my multiplication to random to guarantee that I pick a random letter? So in this example, generic person is their name, that I get something within range of the string. I don't cause an exception by going out of bounds. I don't get a negative number somehow. And it is in fact random each time they call random. So what could we do to make that happen? So pause the video for a second, think about this, and what value should we put here? So I hope you thought about it, and we can spot, well, it's got to be in range of the name of the person. So the variable that holds the name is called account holder. So how many indices or spots are there in account holder? Well, we know that there's a string variable, a string method that tells us the number of characters in it. So we can say account holder dot length. Because if the length is 3, if there are 3 characters, the person's name is Cher, then we're saying between 0 and 3, and then it's not inclusive, so that would be 0, 1, and 2. So those are valid indices. So our index will, or our IDX will get a random number that will be an index that is valid within the range of possibilities in this string. If the person's name is Jimbo Jones, however many characters that is, it works. And now, given this index, let's retrieve it. So we'll say our account holder name dot substring from r.idx to r idx plus 1, right? Because that's one character. But now there's a danger. We need to check if it's a space. So let's go ahead and ask that question. Is this thing a space? So if the letter we chose is equal to a literal space, then we're going to attach to our ID not a space, but a 0. And then if it's not a space, then we are going to attach the substring rand letter. Right, so that single character. So if you find a random character, now is it possible that I get the same letter in a row? Yes, but that's fine. This is not what forces uniqueness, so I'm not worried about duplicates. And of course, it's possible that people have same names and same letters in their names. And so I'm fine with that. We're accepting that we might get duplicates. And the combination, now again, the more we build into our ID, the less likely that it is that they're going to be the same. But as a reality, a practicality, it is factually possible that 2 people with different names and different banks and different random numbers could potentially end up with the same ID so far. And that's a problem. So we want to force that not to happen, but we're not doing it just yet. So now the next step, given this, do the same thing for the bank name. Pick 3 random letters from the bank name. If it's a space, put a 0. Actually, we'll say, so let's go ahead and copy this. Let's do this. Let's say, instead of a 0, we'll put a 7. So if you happen to find a space in the bank name, and that's what gets picked randomly, put a 7 instead. Right? So I'm going to tell you, pause the video again, and implement that next phase yourself. 3 times, 3 random characters, and from the bank name, and if we happen to see a space as the choice, don't put it in a string, but put it in our ID, but put it a 7 instead. So pause the video, try it out, and then we'll come back. Okay, so if you pause the video and pull this off, I think we can hopefully see that essentially the work is the same. The difference is which variable we're referring to. Instead of the holder, it'll be the bank name. And then instead of a 0, we'll put a 7. So I'm going to take strategic laziness, copy this loop, paste it, and then adjust these things. So bank name, there's our bank name. Again, notice that it's still, the code doesn't change in terms of the range, and it's still correct because it's the length of the bank name. And that's the whole idea. This is context sensitive. These methods, length is not a static method. It's actually a non-static method that, of course, the context is not just the name of the method, but well, which characters are in the bank name. And so this works out effectively. And substring is the same way. And then we change the 0 to a 7. So there it is. And so now we have the first 3 random digits, the first 3 random letters from the name, the first 3 random letters, not first, but the random 3 letters from the bank name, and now the last part, and this is what's going to require something new from us. Some number, any number at all, that guarantees uniqueness. Now, is it possible to maybe say, well, I'm going to pick a random number, and then just make sure that no one else has it? And that is actually not a terrible idea, and that's maybe a realistic scenario because it's possible that bank accounts may have a number. But from the perspective of the design of this bank account, it is not possible to do because we are the blueprint. So I don't know when someone's going to make a bank account. I don't know what value they're going to get. And I don't know what they're going to put in this thing. So we can't just say, well, check everybody else's number. Where is everybody else? This blueprint doesn't have access to things that exist. It is the blueprint. Right? Someone might create a bank account based on this blueprint, but once it's a bank account is created in RAM, it's on its own, and this blueprint can't do anything to it or validate or check it. It can only check the thing that it is in that context. So like imagine if you were building it from the blueprint, it's the one item. So we don't know that. Instead, we're going to take a different approach, which is going to seem kind of silly because we used a lot of the same terminology, but essentially what we're going to do is we're going to make another instance variable, but we're not going to call it an instance variable anymore. We're actually going to make it a little bit different. So I'm gonna go down here. I'll put it down here, and we will say to help with ID uniqueness, we will use a static variable. And so now here's the thing. Static, again, I know we might know what the word static means, unchanging. That is not what it means in Java. Here, static is closer to the word shared. So, and we'll say this in kind of the comparison between the two. If an instance variable is a copy given to each instance of an object of this class type, so if every bank account has its own copy of a balance, those are instance variables. Static variables instead say every copy, every object unique in RAM of this class type shares one variable. It's not a duplicate for each one, and so static variables are shared variables. Now, why didn't they use the keyword shared? It's a good question. Other languages use the word shared. They choose not to. Java chooses the word static. And so that's a big difference, right? It's kind of like, personal property versus community property, right? If we live in a community, there may be a park that we all pitch into. We all go to the park. We all clean the park. We all see it. But then we all have our own houses, our own personal cars, our own bank accounts, whatever they might be. And so instance variables are unique personal copies to objects. Static variables are shared across all objects of the same type. That said, when I say objects of the same type, that means bank account objects can see these bank account static variables. Strings can't. Scanners can't. So does the scanner class have some static variable inside of it that we may not know about? And the answer may maybe. Do strings have some static variables that maybe exist inside that we don't know about? Maybe. And we can't know because they may be private. And even if we knew they were there, we couldn't access them because they're only accessible as an object of a bank account because they're not for bank accounts. So when we make this variable, it's for bank accounts. It may be shared, kind of like the community chest, but only bank accounts can see it. And so we're going to go ahead and do that. And so to make a static variable is very simple. Just like with the method, we're just going to add the word static. So we're going to say, I'm going to put the format, just so we're reminded, it's going to be access modifier. And here we're going to put the word static in front of the data type, and then our variable name. So it's basically like an instance variable, but with the extra word static. So here we go. Let's make one. And now I'm going to say, we're going to pick just a number, an integer. And we're just going to kind of bump up the integer. Every time someone makes one of these bank accounts, they will use this number and then increase it. And because it is shared, if someone uses it and someone changes it, everybody sees the change, right? So the difference from an instance variable, if we look at our tester, when account 1 deposited and withdrew money from its own balance, that had zero effect on account 2. That is not going to be true for static variables. Static variables will, if account A changes it, account B will see the change. And so again, the benefit of shared is that there's only one copy, so there's less RAM used. Everyone can see it. Everyone can see the change. The disadvantage, if you consider it one, is that if one person makes the change, everybody sees the change. So if you're relying on a number to be a variable to be a particular value, and it's shared or static, you are at risk of being wrong about what value it contains. Here, thankfully, we don't care what value it contains. We just care that it's a value that no one else has seen so far. So we will say private, because we don't want anyone outside of this class to use it directly. We'll say static, we'll say int, and we'll call it next. We'll call it next unique. And what we'll do is, and here's another scenario that's, again, not common, but we'll do it here because it makes more sense. Typically, you do not assign values to instance variables outside of a constructor, because how could you know what they're going to be? Right? They're meant to be copies, so not everybody has the same balance, so you don't want to give it a value until they call the constructor and give it to you, whether the default or not. Static variables are a little bit different. We can say, well, if everyone's going to see it, we maybe want to initialize it to some number that everyone sees to begin with. So what we'll say is, initially, this unique variable has the value 1. So whoever looks at the variable first, they're going to see 1. And then maybe they make a change, and then the next person will see the change, whatever that change might be. And so that gives us a guarantee. Well, it doesn't guarantee that it's unique, but if we whatever change we make, as long as it's a safe, consistent change, then theoretically no one will ever have the same number. So there it is, right? And so this should be guaranteed. So we'll say static variables are shared across all objects of the class type. Right? It's really important to understand that it's only across the objects of the same type. So classes may have static variables, and anybody that is of that type, of that class, will have this. So now suddenly, whether we know it or not, account 1 and account 2 have access to this variable. So we will now go back and finish up our usage, and we should hopefully be able to complete our method. So we have this unique variable, it's shared, and now why is this good for us? And the answer is going to be, well, I'm going to refer to the variable, attach it to my unique ID, and then change the variable. And I'll do it by change it by just adding 1. So anytime someone calls this method, they will use the variable that is shared and change it. So that means that no one can ever see the same value, because if I'm number 1 and I look at number and I see the variable, and then I add 1 to it, it becomes 2. And then the next person comes along, they're not going to see 1, they're going to see 2 because I changed it. And then they're going to use 2, and then they're going to change it to 3 by adding 1. And the next person will see 3, and so on. So the work that we're doing now, if we did some kind of math that was random, then it would still be possible to get the same number. But if we're only adding 1, I mean, there is a scenario where it might screw up, and that's if we go beyond the size of an int. But I'm going to say, for the sake of our context, there will not be over 2.5 billion or 2.25 billion bank accounts. So the likelihood of getting to an integer big enough to flip over to the negative number will not happen. Right? There are not going to be over 4 billion bank accounts in my system. If there are, then I'm going to be really impressed, but I don't think that'll happen. So let's go ahead and do that. After our loop, let's go ahead and say add the unique static value and update that value. And so here it is. We can say our ID is given to it, attached to it. At the end of it is, we'll go ahead and just put a dash. Oh, and I forgot to put the dashes. That's another mistake I should do. So I put the 3 numbers, and then ID plus equal dash. There it is. So I'm going to put the dash, and then I'm going to put another dash here. There it is. Oh, my semicolons as well. And then I put this one, and there's the dash. And then here's our dash. Oh, there it is. So now here we go. We're going to say our ID is given the unique identifier, which we called next unique. And then I need to update that next unique. If I do not update it, then the whole premise is broken. So I need to make sure that the job that I'm doing is not only referring to the variable, but changing it so that the next person does not see the same value. So next unique. And changing it in a way that guarantees that it is not repeated. So adding 1 guarantees that nobody is going to see the same number. So I'm going to increase it by 1. And then now the last result is, if I did this correctly, ID contains a string that has all the things I expected, and I can return it. Because this is a method that returns a string, so we're going to say return ID. And there, that error, that final error, will go away, and there's our method. Okay? Not too complicated. It's a series of steps, but none of these steps on their own is particularly challenging. We're saying pick a random 3 numbers, add the dash. Pick the 3 letters, make sure there's no spaces, and then add a dash. Pick the 3 letters randomly, make sure there are no spaces, and then add a dash. And then take the unique number, and then change the unique number, and then that's our ID. So we'll finish this video. We're going to have more content to go through, but we'll finish this video by proving this works, or saying that it doesn't work. Maybe we messed up in some way, but or I messed up in some way. Let's test it. Oh, we did make the ID, so we should probably make an accessor and a mutator to make this happen. So let's quickly do that. So here's our accessors, and let's make another accessor. And we'll say public string get ID, and we will say return BID. There it is. And then we'll make a mutator, the same thing. Well, actually, we won't make a mutator because we don't want them changing it, because if they could change the ID, they could break the rule of uniqueness. If they can only see it, they can't ever ruin our ID. So actually, it's much smarter to not give them an accessor. I mean, a mutator, right? I don't want them editing the ID. They can change the owner, and that may no longer match up with the ID, but it doesn't matter because the ID will still be unique, right? And they may change banks, or the account may be transferred across banks, which I don't even know if that can be done. But still, the ID should theoretically be unique. Now, the reality is, if the only way this works, of course, across multiple banks, is if our system is used across multiple banks. Right now, if someone wrote code for one bank and someone else wrote code for another bank, and they had their own ID systems, then that maybe wouldn't work. But our claim is that this whole scenario is that we're one software company that works with many banks. So everyone that's in our collection of banks is protected with this uniqueness, right? So let's go ahead and test this. I'm going to save this. Let's go to our tester. Oh, actually, no. Let's go back and let's edit our display. We made a method called, I believe, did we call it? Or did we not do that? Did we just print it out manually? Oh, yeah, we just printed out the balances. We should potentially display some nice format for that. So we'll do that in a moment. But first, let's go ahead and just test our IDs. And so we'll do system.out, and we will say account1 ID, and we'll attach account1. Of course, we didn't do this yet, but we need to fix it because we didn't actually give it an ID. That's kind of a huge problem. And I'll go ahead and copy this and so fix this. And then we'll say account2. Of course, there's still a giant problem, and so let's go back. I forget myself. Is that in the constructors, we must give them an ID. So here, the default, we are not being given anything. So just like before, we'll just assume it. What's nice now, though, we can say our BID is equal to the method call, right? So we can just say, you know what, call this method and make it work out nicely. Now, I want to point out something. To call the method, again, is pretty easy to do. We can just call the name of the method because we are in the class. Or if you like the style of object.method, which is dot notation, then the object that we're referring to is this class itself, so we can use the this keyword. And so I'll come back to this at some point, but for now I'm just going to call the method directly, and I'm going to say generate ID. So they call the constructor one time, it generates a unique ID, right? And then we're going to do the same thing for this one. We're going to say BID is equal to generate. So no matter which one they call, no matter how they construct their bank account, they will have a unique ID generated. Now, there is one, I don't know why it's complaining about this method call. That's fine. There isn't a kind of a point we have to make sure is notice that I did not change the parameters to this constructor because, again, even though they must have an ID, they don't get to pick what it is. They pick it based on their holder and bank name, and then we do some extra work. So now, if we save this and we go back to our tester, let's see what happens. So we'll run it. We should compile our code, and then there it is. And so there it is. So 671, COG, and IIE, and then 1. And again, these letters are from their input, and so for the default constructor account 1, it's from generic person and generic bank. And then from this one, in our example, it was Jimbo Jones and then Wu-Tang Financial. So if I run it again, we should potentially get some other letters. And there it is, right? 757 and then S and so on. And notice there was a space, so that means that we got a 7 instead. I haven't seen any zeros here yet, so we haven't hit the space in Jimbo Jones, right? Let's run it one more time. And notice that each time we run our program, when the class bank account is created, it starts off with 1 and then every one that goes up. So now, can we really prove that this is guaranteed, that these numbers are unique? The answer is yes. We could maybe print many of them. So why don't we do this? And I'm just going to make a bunch of generic bank accounts, and they're not going to really exist for very long. They're only to prove the point. So why don't we loop and print 10, or create, and then print out the content of 10 bank accounts. So we'll say for int I equal to 0, I less than 10, I plus plus. It's 10 times of iteration. And we'll make a bank account, which is a type. And so we'll call it B. And we'll say these are equal to new bank accounts. Right? Again, what content they have is irrelevant to me. We'll just, that's it. and then we will print out their their ID. So here we go, and we'll say not account 1, but b dot get ID. So then what happens is when these loops, each iteration ends, yes, B is destroyed, but we printed out the content, so we'll at least see them. So I'm going to argue that these first two will always be 1 and 2, and then these will be 3 to 12. And there they are, right? Again, they're all using generic, so these are possible to be the same. These are possible. I mean, these are possible. Well, that's super unlikely to get zeros for all 3 of them, but there it is. But notice these numbers are always going to be different. There's no way to duplicate them because if this person is constructed, they change the shared variable. Then this person is constructed, then they change the shared variable. And then each of these calls to the constructors make a change to the shared variable. Static variables are useful. You have to be very careful because there's certain scenarios where they maybe are not a good idea. But generally speaking, if we have some content that can be shared, it minimizes RAM usage, which is great. And it protects us from scenarios where this is a good simple scenario where uniqueness can be solved relatively easily. Now these are not great IDs, 1, 2, 3, and whatever, but if we had some way to guarantee interesting random looking things that were still unique, then maybe it would be nice to use that instead. But this is a good enough solution for our small example. So we'll end this video here. We'll continue with some more class stuff because classes are a very big deal in our next video.